Okay, so for today, what I'll do is I've chosen a few questions from Laplace transform and its properties and likewise that I believe will help us understand Laplace transforms, at least from a control engineer perspective, a bit better. And yeah, so let's start discussing the questions. And you guys are free to interrupt me at any time if you are not able to understand something. And if there are some particular thing that you would like to understand, which you can like either you can interrupt me after when I take a pause within the questions, or you can say now if there is anything in particular that you want to know about Laplace transforms or anything like that. And maybe we'll start in a minute or two. Okay, so I'll begin, and if there is any issue with my audio, kindly interrupt me as soon as possible. So yeah, rules for applying initial. Okay, yeah, we'll discuss that in one of the questions. How and when IVT and FVT can be used and they fail. Okay, yeah. So I'll begin now. So for today, the first question that we have is consider a signal y of t which is related to two signals x1 and x2 given by this term. Okay, so basically y of t is the convolution of two signals. The two signals are then like some time shifted or inverted version of two known signals that we have. So first of all, we know x1 of t and x2 of t, sorry. So we know that if we have a function of the form e to the power minus at u of t, then it is transformed into 1 by s plus a, right? So for this, let us first take x1 and x2, right, and find their Laplace transforms. So x1 of s is what? 1 by s plus 2, because this is directly in the form e to the power minus 2t ut u of t. So yeah, so x1 of, okay, I guess we can wait 1 or 2 more minutes. Okay, we can resume. Yeah, so what I was saying is we have y of t given in this form, and we want to find the Laplace transform of y of t, that is y of s. So first let us find the Laplace transforms of x1 and x2. So x1 and x2 both are given directly in the form e to the power minus at into u of t. So we know its Laplace transform is directly 1 by s plus a. So x1 of s is 1 by s plus 2, x2 of s is 1 by s plus 3. Now, okay, then the next thing that we know is the Laplace transform of two signals that are being convolved is nothing but the multiplication of the Laplace transforms. So now we have the basic structure of the problem. Y of t is given as a convolution of two signals, right? And the two signals themselves. So if we can find the Laplace transforms of those two signals, then the Laplace transform of y is nothing but the multiplication of the corresponding Laplace transforms. So now x1 of t we know, but what is the Laplace transform of x1 of t minus 2?
Sir,
This is,
sir,
yeah.
excuse me. Sorry, I just now joined. Can you come again, sir?
Yeah, okay, I'll go through it briefly. Yeah. So basically, I'll repeat once more. y of t is given as the convolution of these two signals, x1 of t minus 2 and x2 of minus t plus 3, where we know
Sir, what is convolution, sir? What is convolution of?
okay, so convolution operation x1 convolution x2. Okay, so this is the definition of convolution.
Okay, sir.
So I'll just shorten it. Okay, now we are given x1 and x2, but the two signals being convolved are a little variations of the given signals. So first we'll find out x1 of s and x2 of s, which is direct from the fact that e to the minus at u of t is using when we Laplace transform that signal, then we get 1 by s plus a, right? So Laplace now, and the other thing that we know is the Laplace transform of convolution of two signals is nothing but the Laplace transform, like the multiplication of the Laplace transforms of the two signals. So we just have to find out Laplace transform of this term and this term.
The
Now,
Laplace term of, sir, Laplace transform of x2 minus t plus 3 should be minus 1 by minus s plus 3, no?
minus 1 by minus x plus 3.
1 by minus s plus 3, no? Because
Yeah,
it is coming minus t.
we have not yet written the Laplace transform of like this is the Laplace transform of x2 of t. This thing, e to the minus 3t u of t. Is that fine?
That is, you are telling that e power minus 2t is written, okay,
Yeah,
understood.
yeah. I'll go to that step what you're talking about. Okay, so then, so next we want to find out Laplace of x1 of t minus 2. Now using the time shifting property, we know for a fact that this is just x1 of s into e to the power minus 2s. So here we have e to the power minus 2s by s plus 2. Okay. So similarly, now we want to find out the other signal. So first, from x2 of t, first what we'll do is, we'll find out x2 of minus t. Now, we know this thing, x of at is equal to 1 by mod a into x of s by a. Right? So from here, we know this is minus x2 of minus s, right? So this is minus 1 by minus s plus 3, that is minus 1 by 3 minus s. Sorry, this minus 1 won't be there because it is just minus 1 by mod a. Okay. So this is 1 by mod minus 1.
You minus that 1 by mod a. 1 by mod a.
Yeah. So
Can you write that again?
yeah,
Erase it.
L of x2 some x of at, 1 minute, x of at is equal to 1 by mod a x of s by a. This is a known property of Laplace transform. So when we use this to implement here, then the scaling factor a is nothing but minus 1. So what we'll get is 1 into x2 of s by minus 1, that is minus s, right? So here what we'll get is 1 by 3 minus s. Now next step is we are time shifting this signal. That is, we want to find out L of x2 of minus t minus 3, right? Because we have minus t plus 3. So this is again just a time shifting thing. So with this Laplace transform, we'll only multiply e to the power minus 3s. That is e to the power minus 3s by 3 minus s. So finally,
I am not getting that last minus t minus 3.
okay. Yeah, so first, till this part it is clear?
Up to that it is clear.
Okay. So now if we consider, say I'll define h of t as x2 into minus t, okay? Right? Then I want to find out what? I want to find out the Laplace transform of this thing, okay? Because we have that here. So I can write this x2 of minus t plus 3 is nothing but h of t minus 3, right? Because this is equal to x2 of minus t minus 3. So this is x2 of minus t plus 3. So I want to find out the Laplace transform of h of t minus 3. So that is e to the power minus 3s into hs. But hs I know already, which is this term, because h of s is Laplace transform of x2 of minus t. So that is e to the power minus 3s by 3 minus.
Sorry, I am not getting you. Come again, sir, please.
Okay.
Sorry.
Yeah, no issues. I'll just zoom in a bit. So I'll begin from the start. What do we have? We have first x2 of t is what is
Yeah.
it? What is x2 of t? E to the power minus 3t u of t. Okay.
Yeah,
So
okay,
we
correct.
know Laplace transform of this is 1 by s plus 3. You agree with this?
Yeah, correct. This is the formula, no? 1 divided by s plus
this
3.
is formula only. 1 by s plus
Okay.
3. Yeah. So
Yeah.
then next is I want to find the Laplace transform of this thing. Okay.
Yeah. E4.
So
That is then equal to 1 by s minus 3.
no. So
No, sorry.
we'll
1
write
by,
that thing. Hold on.
yeah.
We'll just write step by step. And this is x of at is equal to 1 by mod a capital X s by a.
X,
Right?
s by a. Yeah,
So
correct.
basically in this function we'll replace s by a and multiply 1 by mod a on the outside. So that
Correct.
is minus this thing into 1 by minus s plus 3. That is we replace s by minus 1. So
Okay.
this is 1 by 3 minus s. Correct?
Correct. Understood.
Now next step what I'll do is I'll define a new function, okay, h of t as x2 of minus t. This I define, okay, I just define this way. Then
Okay.
what is
You are defining or you are assuming, sir? This is.
yeah, I am assuming h
Okay.
of t, like I am taking a new function and defining it in this way. Okay. So
Okay.
h of t minus 3, what do I get here?
E power
X.
yes into h of s.
Sorry, I didn't get that. Could you repeat?
Before going to e power minus 3, x2 in bracket minus of t minus 3. Correct, no?
Yeah, correct. So x2 of
x2
minus
of minus 3 minus 3.
So this is
Then multiply
x2
inside x minus t plus 3.
Correct?
Then substitute this minus t plus 3 in that equation. Equation
Yeah,
x of t.
hold on. Till this point it is clear?
Yeah, clear.
H of t minus 3 is x2 of this minus t plus 3. Now,
Yeah.
that is the term we want to find the Laplace transform of. Okay? So, now I want to find the Laplace transform of h of t minus 3. Right? Now, this is just again time shifting, and we know this is e to the power minus 3s into h of s. Where h
Now,
of
this
s,
is how you are defining. This is a formula or how it is? Time shifting minus
this
e
is
power
also
minus
a
3s.
formula. I'll write it.
Yeah.
It is x of t minus 3.
Because I am doing this after a long time. Okay.
Yeah, this is the formula. Okay. So, e to the power minus 3s into h of s. Now, h of s is the Laplace transform of h of t, which is Laplace transform of x2 of minus t. And that thing we had here. So, this will be e to the power minus 3s by 3 minus s. Till here
How
it is
x of s is, sir, how x of s is Laplace transform of x of t, h of t?
h of s is Laplace transform of h of t.
Of h of t. Okay. Then Laplace transform of in h of t.
I replace this definition.
Okay.
Correct?
Understood.
Yeah. So what we had is Laplace transform of y is equal to Laplace transform of this x1 of t minus 2 into Laplace transform of x2 of minus t plus 3. I have obtained the 2, so what remains is just to multiply it. So everyone is clear in this question, or any doubts? Please don't hesitate, you can ask any.
No
Yeah.
doubts.
No doubts? Okay, sure. Okay, then we move on to the next question. Find the inverse Laplace transform. Yeah, go ahead.
कॉन्वोल्यूशन थ्योरम में तो ये बोलता है ऐसे कि अगर मेरे पास दो फंक्शन है तो लैप्लास ट्रांसफॉर्म ऑफ दोनों का प्रोडक्ट जो होता है लैप्लास ट्रांसफॉर्म ऑफ f1t इंटू एफ ऑफ टी, उसके बाद हम लोग दोनों का प्रोडक्ट का इन्वर्स करते हैं। लेकिन यहाँ पर हम लोग ये डायरेक्ट हम लोग लैप्लास ट्रांसफॉर्म ऑफ f1t इंटू एफ ऑफ टी इज इक्वल टू डायरेक्ट लिख दिए सर लैप्लास ट्रांसफॉर्म ऑफ फंक्शन 1 एंड फंक्शन 2। ये तो कंडीशन है ना सर कन्वोल्यूशन के लिए।
क्या कंडीशन है कन्वोल्यूशन के लिए? मैं समझ नहीं पाया,
सबसे
थोड़ा बोलो।
मतलब मेरे पास कोई दो गो फंक्शन है सर f1 ऑफ t एंड
f2 ऑफ t। ओके, हाँ।
तो हम लोग को कन्वोल्यूशन निकालने के लिए मतलब f1t इंटू एफ ऑफ टी निकालने के लिए हम लोग कन्वोल्यूशन थ्योरम का यूज करते हैं। तो सबसे पहले हम लोग फंक्शन 1 का लैप्लास ट्रांसफॉर्म निकालते हैं, फिर फंक्शन 2 का निकालते हैं।
हाँ।
और उसके बाद फिर जो लैप्लास है उसका इन्वर्स कर देते हैं। वो मेरा जो रिजल्ट फाइनल आता है वो मेरा लैप्लास निकलता है, मतलब दो प्रोडक्ट फंक्शन।
नहीं, मतलब कन्वोल्यूशन थ्योरम सेज दिस दैट द लैप्लास ट्रांसफॉर्म of the convolution of two functions is the Laplace transform of f1 into the Laplace transform of f2.
Yes.
Correct, na?
Yes.
Sir, convolution in time domain is equal to product in Laplace transform.
Domain. Yeah, correct.
So then the left side Laplace transform will not be there. That is the reason I mentioned the comment.
No, okay. No. See, the thing is, convolution in time domain is equivalent to multiplication in frequency domain, but that does not mean we can write this thing. Because if you say take some x of t and say delta of t. Their convolution is x of t, right? But you don't write that the convolution of two signals is equal to Laplace of x and into Laplace of delta t. Correct. So
That is the convolution theorem, sir. That is only the convolution theorem.
okay, I'll just show it to you. So suppose I have x of t is equal to sine t, okay, and delta t is equal to, like, delta t is the impulse function. So what is the convolution of these two?
Sin t. Okay.
Sine t.
Hmm.
So, and what is the Laplace, like multiplication of the Laplace of these two?
Sir, how it is sin t, sir? X of t into delta t means sin t into delta t should come, no?
Sine, this is not into, this is convolution, the thing that we mentioned earlier. X of
X
tau.
of t, x of tau into x of t to t minus tau d tau. Okay.
Minus infinity, yeah. So
Yeah. Can
it
you
turns
explain?
out that when we convolve any function with delta t, we get x of t itself.
Okay.
Okay, so just assume that for now.
Okay.
And okay, so Venkata, you agree with this? X of t convolved delta of t sin t.
Yes, sir.
Now, what is Laplace of x of t?
1 by s square plus 1.
1 by s square plus 1. Correct? And Laplace transform of delta of t?
1 or e power minus.
Yeah, 1. So, Laplace transform of x of t into
Sir, how
Laplace.
it is 1 by s power s square plus 1?
This is also a known formula, like when you put sin t in
Okay.
the Laplace transformation, you can directly get it. Just integrate this thing.
Okay.
Then, okay.
So we have to remember all these small transform functions.
Yeah, basically once you derive these basic ones 2 or 3 times, like it will be on the back of your hand. Like
Okay.
for beginning, maybe you can remember a few times or prove it, derive it on your own. Then you can, it will basically be there.
Okay.
So
Can you explain me x of t equal to sin t, how it is becoming Laplace of x of t equal to 1 by s square plus 1? Can you explain me that formula? You are writing some formula. Sin c e power minus t dt equal to what, sir?
yeah, okay.
Sir, if you are asking with the basic formulas, then it will be difficult to solve the problem. You should know few basic formulas by yourself, sir. Please.
Okay, I'll just write the formula once. You can check it up in any textbook. It is very easy to derive. So Laplace transform of sin t, sin at is s by s square plus a square. That is correct, right? Sorry, this is no, this is for cos. This is a by s square plus a
By
square.
s square plus
Yeah,
a square.
yeah. Thank you. So now. Now we go back to this question. Laplace transform of x of t into Laplace transform of del of t. So Venkata, what will we have here? It is just 1 by s square plus 1, right?
Yes.
So what you are claiming is this is equal to this, right?
Yes.
But
So
I mean, we say that very casually, like the convolution of two signals in time domain is equal to multiplication in frequency domain. But what we mean is essentially the Laplace transform, like when I convolve two signals in time domain and then take that result into the frequency domain, that result is nothing but the multiplication of the Laplace transform of the individual signals. Okay, so Laplace of x1 convolution x2 is Laplace of x1 into Laplace of x2. Yeah?
Okay, sir, got it.
Yeah, sure. So, any further doubts? Maybe we should move on.
Sir,
Yeah.
hello, sir. Sorry for intervening, but sir, how it came like delta t Laplace of delta t is equal to 1. So how it came?
That is basically, okay, I'll do this one. Del of t e to the power minus st dt, right? Minus infinity
Yes,
to
okay,
infinity.
sir. Is it impulse function, sir?
Delta of t
Delta.
is the impulse function. Yeah,
Okay, sir. Okay, sir.
yeah, sure.
If you are trying to explain, can you explain, sir? Since you have gone complete it.
Okay, sure. So delta of t, we know it is, so when we integrate delta of t, we just take the value at 0. Like the integration is e to the power minus s into 0. So this is 1. Like this is the property of a like impulse response, impulse unit impulse function. So you can check it up in any textbook, you'll find it. So I should move to the next problem. Okay, for the next problem we have find the inverse Laplace transform of this given transfer function. So can anyone help me with this?
Yes, sir.
T power minus 1 of s. Laplace transform of g power minus 1 of s.
Yeah.
So in the first
Go ahead, Vishal.
in the first place, we have to find out the partial fraction of this.
Yeah, so maybe you guys can try and help me with decomposing the function.
I
Yeah,
can just
yeah, go.
in the denominator में से a square plus 2s plus 1 है मीन्स s plus 1 का स्क्वायर है और ऊपर हम ऐसे तोड़ेंगे x plus 3 को कि x plus 1 plus 2 करेंगे सर डिनोमिनेटर को चेंज करेंगे 1 plus 2 से ऊपर और यस सर और फिर इसके बाद हम लोग ये फ्रीक्वेंसी शिफ्टिंग जो प्रॉपर्टी लगाए थे वो करेंगे e के पावर माइनस टी yes.
Correct. So we can see that just a minute. Let f of s be of Laplace transform of some function given by this thing. Okay. So then we can see that g of s is f of s plus 1. So we know this is just a frequency shifted thing. So maybe we can find f of t, that is the inverse Laplace transform of f of s, and then from there just multiply e to the power, like that extra term that we need to multiply to get the frequency shifted output. So for this,
Sir, please explain with one example, sir. Otherwise, not getting up to this clear.
Yeah,
whatever up to
I'm doing it. Just be a little patient.
Yeah.
So 1 by s we know it is u of t, and 1 by s square we know it is 2, like 2 into 1 by s square, it is 2t, right? Then f of t gives us f of s, but we want g of s, right? So we want the frequency shifted thing. So we will just multiply, since we are having f of s plus 1, we'll have to multiply e to the power minus 1, minus 1 t. So the actual thing g of t is equal to e to the power minus t 1 plus 2t u of t. Did everyone follow on this?
No, I'm not getting last statement.
Which statement?
First, you are writing g of s equal to f of s plus 1. It's a formula or how it is?
G of s is f of s plus 1. We can see it from the, like this is g of s and this is f of s. So f of s plus 1 is g, right?
F of s plus 1. Okay.
Yeah.
F of s plus 1 is g. Oh, yeah, correct. Okay, understood. That I am understood. Okay, sir. Next, sir, that g of t equal to e power minus t. How do you derive that?
So this is another formula. I'll write it. Laplace transform of e to the power minus at f of t is equal to f of s plus a. Okay, from this you can easily yeah.
Yes, the frequency shifting properties.
Yeah, so everyone else follows, right? Yeah, okay.
सर here Laplace transform और ये shifting property जो लगाए हैं तो उसके बाद g of t is equal to e के power minus t1 plus 2t ये क्या ये नहीं समझ में आया।
कौन सा e of t1
g of t is equal to e के power minus t into 1 plus 2t सर ये कैसे आया सर ये क्या है?
अच्छा ठीक है,
ये भी कोई प्रॉपर्टी है क्या?
नहीं ये प्रॉपर्टी नहीं है। ये f of t ये आया समझ में आया 1 plus 2t into करेक्ट। तो f of t से हमको f of s मिलता है, बट हमको g of s चाहिए जो कि f of s plus 1 है, करेक्ट?
यस सर।
सो f of s plus 1 चाहिए, तो हम अगर लेफ्ट साइड में बस e to the power minus t मल्टीप्लाई कर दें तो हमको f of s plus 1 मिल जाएगा, राइट?
Yes sir.
So basically L of e to the power minus t f of t is equal to f of s plus 1, which is gs that we want. So the inverse of gs, Laplace inverse of g of s, is nothing but e to the power minus t f of t, right? जो कि है e to the power minus t 1 plus 2t u of t, करेक्ट?
Yes sir, correct sir.
समझ में आ गया ना?
Yes sir.
चलो आगे चलते हैं। Yeah. So this is the next question that we want to find out, the Laplace transform of the given time varying function. So for these questions, the standard approach that we take, this is the given function, right? So this is not in terms of any known functions. So what we want to do is we want to break this function into terms where we can get the things in like known components, either step function, impulse function, or some function like that, some linear or t square or something like that. Okay, so we'll see how we can break this function, and maybe if you so using that approach you can break any other complicated function as well. So let's start with this one. So f of t, we know it is just some till 0 to t time, till here it is just a constant thing, okay? So suppose we have this constant kind of thing, then let us take that first, okay? Like we have something like this t. So how do we represent this? We can write this thing as u of t twice minus,
क्या मैं बोल सकता हूँ?
हाँ बोलो।
यस, ये सबसे पहले मैं यूनिट स्टेप सिग्नल दूंगा सर t इज इक्वल टू 0 पर, और फिर शिफ्ट कर दूंगा सर t सिग्नल से, और उसके बाद फिर दोनों का एडिशन करेंगे तो जो मेरा राइट साइड में है वो मेरा कट जाएगा सर।
जो राइट
तो
साइड में, हाँ ओके, मैं एक बार
दोनों सिग्नल को सब्ट्रैक्ट करूंगा तो
हाँ
कट जाएगा
जो दिया। सो नाउ इफ वी राइट u of t is just 1 for the entire duration from 0. Now u of t minus some capital T, that will be 1 after time t. So if I subtract these two, till this part there won't be, like we'll have only this portion 1, but after that part, for this part the 1 and minus, like 1 and 1 will cancel each other, right, because we are subtracting. So u of t minus tau, capital T, just becomes something like a pulse signal. So we can write this pulse kind of part as this thing. Now we want to see how we can write this line. Okay, that we can write as, so first of all it is just a straight line, okay? So maybe I'll try to extrapolate it, and going by the slope, this should be minus 3, right? This is 3t. So slope is 1 by t, and this is just a straight line with some intercept. So we can write the formula for that. 1 by t right, this is the equation of the line that would have been like this, like the entire line, but I want it to be only in this fixed part, right? So for that, again what we can do is we can take two step functions and just clip them off like we did for this case. So we'll multiply with this star minus u of t minus 3t, right? So
Okay, but 1 by t, how 1 by t comes? Actually 1 by 2t it should be, no?
why 1 by 2t?
Because from t to 3t we are taking, no? The difference is 1 by 2t, no?
Yeah, but like 1 by t is the slope of this line, right? 0 minus 2 by 3t minus t, 1 by t.
But you are going up to minus 3, no?
And so slope won't change, no?
Okay.
ग्राफ बना के समझाते तो बेहतर रहता है।
किसका ग्राफ? लाइक लाइन का? अच्छा ठीक है, मैं I'll do this once again. So for now, forget that first pulse part, take only from here, right? So what I am trying to find is the equation of this entire line. So we'll go from the basics, y minus, so what do we have for the formula for the line? Can anyone tell me?
Y equal to mx plus c, like that, no?
Like given
y minus y1, y minus
y
y1 into m into x minus x1
into
x m into x minus x1 equation of line.
So okay, now m is what? y2 minus y1 by x2 minus x1, right? So we found that slope was, this is 0, this is minus 2. So first we'll take this point. So y, that is the, say this is y, x2 y2, this is x1 y1. So y2 minus y1 is how much? 0 minus minus 2, and x2 minus x1 is how much? 3t minus t. So we have 1 by t. This part is clear. The slope of the line is 1 by t.
Okay.
Then
Very clear.
I'll write it now I have y minus y1 is what? Plus 2 is equal to m into plus c. So we'll
Y plus 2, how you got, sir?
y minus y1, y1 is minus 2.
Y1 is minus 2, correct?
Yeah.
So minus minus plus it came. 1 by t you have put. X is t, x is x minus x1 is t.
x1 is 2. Yeah. Then C, how do we find? We plug in another point, say x2, this 0, 3t comma 0 I'll plug in. 0 plus 2 is equal to 1 by t, 3t minus t plus c. So this is 2 plus c. So we find that c is equal to 0. Right? Am I doing it correctly? 2t by t. Yeah, this is correct.
E equal to minus 2, no?
This is 2. 0 plus 2. 2. 2 equal to 2 plus c. So c is equal to 2, right?
Yeah, correct.
Correct. So everyone is clear with how we found the equation for the line, right?
Correct. Sir, but you are taking y equal to 0 is because you are taking horizontal line. Correct now, sir?
Not because
0 plus 2.
like I'm just taking this point. I'm plugging that point back in.
Yeah, understood. That point is 3t. You are plugging 3t. How you are taking yt? You should take minus 3, no? The
This
line is
point
going and interrupt.
This point is 3t comma 0, right?
Okay. Understood.
So yeah. So where were we? Yeah. So the equation of the line becomes y minus y1 is to, where were we? Yeah. Yeah. So this is how we derive the equation. Now you can see that it is equal to this x and y. Instead of x and y, we'll have this f and t. So we'll have this line. Okay. Is this part clear?
Not clear, sir. 1 by t. How you are putting that t minus 3t?
See, if you write this is y minus y1. Okay, I'll just do it. Y minus y plus 2 is equal to 1 by t, t minus t. This is the equation that we had. This is equal to 1 by t, t minus 3t. Is that clear? This is just basic algebra. You can get this. You can check if the equation of the line is correct or not. So now after getting the equation of the line, okay.
Sir, one second. Below y plus 2 equal to 1 by t x minus t plus t. So in the place of x you are putting t minus t, correct? Plus c, y you put 0 because there is no constant. So y equal to mx, so you put 0.
C
Correct, no?
we found out 0, right?
C we found out 0, so we are putting 0 here. And y plus 2 equal to 1 by t, x is t, small t, so t minus t. The first equation is clear. Second equation how you brought?
Just bring this 2 to this other side and
okay.
You can see that I mean,
okay, understood.
Maybe you can try some of the questions yourself. Then if you have later doubts, you can post in the forum, because or else we'll lose track of time. Yeah. So everyone is clear on how we got the line equation, right? So from the line equation, what I want is this line should appear only within the time interval capital T to capital 3 into capital T, right? Only within this time interval. So like we did in the case for this pulse, we can do the same, just that the time shifts will be a little different. So if I multiply this, right, then this part, so this part I can write as u of t minus capital T minus u of t minus 3 capital T. So when I write this function will just be a pulse of height 1 from t to 3t. So when I multiply this function with the line that we had, then I'll just get this part, right? which is what I need. So the original function f of t I can write as 2 times u of t minus u of t minus capital T plus 1 by t minus 3t into u of t minus t minus u of t minus 3t. Okay, so we can represent the given f of t in as this, as like what I have written on the right hand side. This way what happens is the right hand side is composed of step function and a linear function, that's all. So this function now we can decompose it, like take the inverse Laplace very easily, take the Laplace transform very easily, because it is just composed of linear combination of very commonly known functions that we have direct formulas for. So this we can further decompose a bit to make it easier for us. 2u of t minus t plus 1 by t minus t Okay, so I encourage you all to try this, how to get from here to here, but it is fairly simple, only just bring one term from other bracket to elsewhere. So why we did that was, see, you have u of t minus t here and t minus 3t here, so this term, it is beneficial if it is in a function of t minus t, like this one, so that we can directly apply the time shifting property, right? So from here, I can directly write f of s is, this is 2 into 1 by 1 minus 2 e to the power minus ft by s plus e to the power minus ft by ts square minus e to the power minus 3st by ts. So this one, I hope it is clear. Like the major hurdle for this question was how to decompose the given f of t into known into functions that we know very well. Okay, so is there any comment here? Yeah, so I hope it is clear till, yeah, go ahead Vishal.
You did mistake there. So there you have to write a 3t. I think you forgot to write t minus 3t. So
Second function, it will be
right
t minus 3t.
This
Second
one you are
term.
saying?
Yes, sir.
So it is not a mistake actually, like this term you break it into t minus t minus 2t, so that like this entire term you can see is, I'm sorry, someone's mic is on, can they switch it off? Saurabh, your
Saurabh,
mic
please.
is,
Saurabh, आप म्यूट कर सकते हैं.
yeah, so what we did here was this entire function, you can see that it is equal to this. You can check it for yourself. If it is wrong, then we can discuss it again. Like what the main intention behind breaking it that way is to have a t minus capital T term along with u of t minus capital T and a t minus 3 capital T term along with u of t minus 3 capital T. Okay, so that in this function we can directly apply the time shifting property. So if I instead had 1 by t u of t, then I know it is 1 by ts square, right? But if that entire time function is just shifted by minus t, then I can multiply this directly without having much of an issue. So that is why we wrote f of t. We decomposed
So,
it into this.
so we can write t minus 3t is equal to 2t minus t. Is it same?
No, it is not the same. Like this entire thing is same as this.
Okay, sir.
Like different terms are also different here. You can check it for yourself. This entire
sir.
term is equal to this. Yeah, maybe if you don't know, if you find that it is wrong, then you can post in the discussion forum. I'll send the corrected version. Okay, so as far as I think it is correct only, and yeah, so we'll move on to the next question, or yeah, maybe we should move on. Yeah.
Yes,
So
sir, that thing is correct.
yeah, thank you. So yeah, so now we come to that initial value and final value thing. So two important things to know. For initial value theorem, f of t must be continuous or only should have step discontinuity. That is, it should not have terms of the impulse or its derivatives in the function. So like we see in this function, there is an impulse function. So for cases like these, we cannot use the initial value theorem. So we can just check it. So we have this function. If I find out f of s, then it is 1 plus 3 by s plus 1. Okay, so by initial value theorem, limit t goes to 0, f of t is equal to limit s goes to infinity, s into f of s. Right. So, but this thing is limit s goes to infinity, s into 1 plus 3 by s plus 1. This one we can see that it is going to infinity, that is the limit does not exist. Okay, so that is the thing. When you have an impulse function or its derivatives, then you will get terms like this, either 1 or multiples of s, that is the numerator term will have a greater order than the denominator term. So when you take limit s goes to infinity, multiply an s with this thing, like always you will get infinity as the answer, which is not correct. So because the limit does not exist. So for using initial value theorem, you must like the function must not have terms like this, either impulse or the derivative of impulses or anything, like anything of that kind. Is this correct? I think someone was asking a question when to use IVT and FVT. Is the initial value part clear to all of you? Yeah, okay. So, so next question what we have is, we have the final value theorem. This also we'll check it out. Now the final value theorem, similar to that only, like for the initial and final value theorems to be applicable, the limit that we find out, that we want to find out, must exist, or else we cannot write that this limit equal to this limit. So for example, for this case, we have f of s is equal to 3 by s minus 1. So limit s goes to 0, s into f of s is limit s goes to 0, s into 3 by s minus 1. Now this one, the limit exists, it is equal to 0, but we have to check another thing, that the function that we have, it is unbounded, right? E to the power t is just an unbounded function. So for final value theorem, the limit t goes to infinity, f of t must exist. Only then can we use the statement of the theorem to say that limit t goes to infinity, f of t is equal to limit s goes to 0, s into f of s. So when you see the statement of the theorem, if limit t goes to infinity, f of t exists, then it is equal to this thing. So this condition has to be satisfied, that the actual limit of the function, that has to exist. If it does not exist, we can say that the limit is equal to this. So I hope that is clear. So for this function, e to the power t is an unbounded function, so the limit at infinity won't exist, so we cannot say this thing. Okay, is this part clear?
Yes, sir.
I believe someone had asked the question.
Yes, sir. I only asked. It's clear.
It's clear, no?
Good.
Yeah.
Yes.
Yeah, so that you have to verify that whatever limits we are equating, those two limits have to exist. If they exist, then only we can say that they are equal.
If the question is directly in S domain,
Huh.
then do we need to find Laplace inverse? And
If
do we need
the,
to
if the question is an S domain, then I don't think they'll, like, if you have some f of s, then using final value theorem, they'll ask you to find f of infinity only, right? So you have to, yeah, in that case you have to check if the f of t for the given f of s, it is like it is bounded or not, and if the limit will exist. But I think a general approach that we can use is for this f of s, take for example, the pole is on the right half plane, right?
X
So
plus
when,
1?
yeah, s is plus 1, the pole is. So when you have a pole on the right half plane, that means the system is unstable. That is the inverse transform that will have, it will be unbounded. So maybe you can directly use that instead of finding the inverse and doing like checking if it is bounded or not.
Okay.
Yeah. So is it clear for everyone till now? And can we extend
Yes.
it just a little bit?
Yes, sir.
Yeah, sir. Sure, sir.
Thank you. Okay, so now this is just one question. We are given a transfer function and we want to find the DC gain of the system. So can someone tell me what is the DC gain of a system?
2 by 5.
No, not the answer. Just like tell me what do we mean by the DC gain of the system?
The constant that we get in the numerator.
No, see, what do we mean when we say DC gain? Like I have a system.
Frequency should be 0.
Yeah, correct. Those answers are all correct, but they are like the mathematical answer, like what is the DC gain? Yeah, but physically, when we say like the DC gain to a system, I have a system, suppose, and I give a DC signal, then how many times is the given DC signal amplified when it goes through the system? Okay, so I have a system. I give a DC signal, and what is a DC signal? It is basically a constant time signal, right? That it does not fluctuate, no oscillations, nothing, just a constant time signal. So if I have a DC signal, then how many times is the output amplified? So the best way to do this is you just take u of t, which is nothing but a one value DC signal, correct? So this is a DC signal of value amplitude 1. So when I give it to the system, what is the steady state output of the system? So if I give u of t to the system, then output y of t is in Laplace domain, it is g of s into u of s. So it is just 1 by s into g of s. Now the steady state of the output function, I am assuming it exists, is equal to limit s goes to 0 s into 1 by s g of s, right? So this is nothing but g of 0, right? So that is why the DC gain of the system is taken by just substituting 0 into the system. So what this physically means is, I given a constant, say 1 amplitude signal, then the output, for the output the steady state value will be g of 0. So it will settle at that value. So if I give this input, then the output will be, maybe it will have some transient and then settle near to g of 0. So that is why this term DC gain has the name as it has. Like It is how many times is the DC input amplified. That is why DC gain. And directly the formula is this G of 0. Okay, is this part clear?
That is clear. One small doubt can I ask?
Yeah, sure.
This limit s tends to 0, sy of s equal to, how you are writing, why you are writing that s into y of s? What you are trying to tell there, I am not understood.
So, if you see the final value theorem, it says that if I have f of t and I want to find limit t goes to infinity f of t and it exists, then it is nothing but limit s goes to 0 s into f of s.
Yeah.
Yeah.
So why we are applying final value theorem to steady state value, to understand the steady state?
To find the steady state value, that is the output. The output might not be like I am giving this input, right? But the output will not appear instantaneously like the input. It will instead have some kind of transient that will depend on the system. It can be anything. But where it settles, I want to find that value.
That is why you are putting final value.
Final value theorem, yeah.
Okay, understood. Thank you.
So just one final thing, maybe you guys can try this. Is there a system pole located on the right half plane? It is the same transfer function. So maybe you guys can try this. What are the poles of the system? So for finding poles of the system, we equate the denominator with 0. S cube plus. Yeah, anyone have the answers?
Yes, sir.
Yeah, tell.
All are located on left half of the S plane. There is no pole on right half.
Okay, so tell what are the poles?
-1.
All -1.
-1 plus or minus J2.
Yeah, correct. These are the poles of the system. So, anyone has a problem with this solution, or did anyone get other poles? Yeah, okay. So you can just verify. This is just you have to find the roots of the cubic polynomial, and yeah, these are the poles. So we do not have any poles on the right half plane. So with that, maybe we can stop for today. And I hope you guys gained a better understanding of the Laplace transform. And if you have any other questions, then you can put it up in the discussion forum. We'll try to answer it as fast as possible. Yeah.
One question, sir. What does mean transportation lags?
Transportation lag, I think it is something of this form only. E to the power, like whenever I have f of t. So
मीनिंग क्या होता है इसका मतलब?
Physical meaning होता है कि in the sense whenever many times what happens is in control system problems, what you will see is I applied a step input. What that means is I switch on and it instantaneously goes to some value. But in reality that will never be the case, right? So there is always some kind of delay. Or say suppose I have some circuitry for some machine, I switch it on, there is some circuit delay within the machine, and then that propagates, like that adds kind of a delay to the actual input or impulse into the system. Okay, so I guess that is the meaning of transport delay. I'll just check it up and send a write up maybe, transport delay. Yeah, I think that is what transport delay is. Like it will be, that is why the name is also transport. Like whenever there is, you give some signal or some input is coming or some signal needs to reach to some place. Like when you are measuring the signal as well, like you'll have some oscilloscope or something else. So time needs, like it needs some time to propagate the energy and all to reach to you, or whatever input you give, that takes some time. So these are known as transport delays. and they appear in real systems. So I hope with that,
Yes, sir.
yeah, we can close the session for today.
Sir,
Yeah,
one
go
more
ahead.
question.
Yeah, sure.
If f of s is equal to 1 minus e के power st by s is the Laplace transform of मैंने ग्रुप में भेजा था सर
Uh,
1
one
minus e के power st सर
e की power st, हाँ,
by s
by s,
is the
हाँ.
Laplace transform of
This,
ऑप्शन में जैसे कि pulse width और a pulse of width t a sequence of wave of period t
हाँ, तो पहले तुम
Yes.
इसका ये बोलो कि f of t क्या होगा इसका?
तो u of t minus 1 base 2
This is just a time shift, right? So this is minus u of t plus t, right? No, no, minus t. Correct?
yes.
So this we saw today, no? If I have u of t and I subtract u of t minus t, then what I get is a pulse of width t. This is a pulse.
Yes.
Yeah. So I'll stop the session now. Thank you everyone, and we'll meet the same time next week